This is example 7. This video, we're going to look at finding everything we need to know about rational functions, and then we're going to graph the function. So this example, f of x is 3x divided by x minus 1. Start with the domain. Set the denominator not equal to 0 and solve. So x equals 1 is excluded from the domain. Possible whole, possible vertical asymptote. Who can tell? Find the x-intercept, set the numerator equal to 0 and solve. So x equals 0. This represents the origin. This will also be the y-intercept, but we'll look at it in a second. Now find the wholes. Simplify the function. Always simplify the function to find the wholes. This one is completely simplified, so evaluate it with the number excluded from the domain. We still divide by 0. This is not going to be a hole in the graph. This is going to be the vertical asymptote. So x equals 1 is the vertical asymptote. Always write asymptotes as equations of lines. Y-intercept, well, we already know it's the origin because the x-intercept is the origin, but evaluate the function using x equals 0, and you see the output is also 0. Horizontal asymptote. Compare the degree in the numerator and the denominator. They are equal. So y equals 3. That's the leading coefficient, the ratio of the leading coefficients. If you have a horizontal asymptote, you have no slant asymptote, and the end behavior model is always one of those things. So y equals 3 in this case. Now let's take a look at graphing it. We're going to start by plotting the intercepts and any holes, and then drawing dashed lines for the asymptotes. Be sure and label everything. You don't have to label the origin, but any other x-intercepts or a hole on the graph, you do have to label appropriately. So now our graph is separated by the asymptotes into 4 areas. But this is a function, so we're only going to be able to draw one part to the left of the vertical asymptote. It'll either be above or below the horizontal asymptote, but not both. And one part of the graph to the right of the vertical asymptote. Again, either above or below the horizontal asymptote, but not both. So let's take a look at a few more details. I need to know whether to plot above or below where I've put the question marks. So does it start at the bottom and go up, or do something else like that? So how do you know where does it go? Well, if you look at the x-intercept, there's only one. So it cannot come from the bottom of the graph crossing the x-axis. It has to be above that horizontal axis there. So let's take a look on the left of the vertical asymptote, and here we can separate it into the left of the x-intercept and then in between the x-intercept and the vertical asymptote. So let's start in the middle between the intercept and the vertical asymptote. So we need to consider, does it do that above, or is it going to do this below? So here you can use a test value if you're not sure. So something between 0 and 1, so x is 1/2. Evaluate the function, see what the output is, and then decide whether you go up or down. So after you evaluate that, you see that you have a negative value, so your function is going to go down like that. And so we need to connect the x-intercept to the left. So is it going to go below the x-axis and come back up? Is it going to go above like that? So again, you can do a test value if you want to and determine that this is the actual final graph. So there you go.